Will the history of astronomy be divided between before Webb and after Webb?
Yes, I believe it will be.
So something real is happening, but we can't tell yet if it's a mistake in our observations, a mistake in our interpretation, or just something nature is surprising us with, such as a new kind of dark matter, a new kind of dark energy, or something else that would be really exciting to discover. So if there's a Nobel Prize in here, that could be one of them.
Take a look at this image. What you're seeing is a distant cosmic structure shining brilliantly in the early universe. The discovery of this luminous object has helped solve a long-standing astronomical mystery. According to our current understanding, the universe came into existence around 14 billion years ago. Following the Big Bang, it entered a period of total darkness, known as the Dark Ages, during which clouds of gas filled the cosmos. Even with the most powerful telescope ever built, we wouldn't be able to see beyond this era. However, for decades, scientists have detected mysterious light emerging from these dark clouds. A recent groundbreaking discovery has ignited intense debate among astronomers. For the first time, the Webb telescope observed two ancient galaxies. Intriguingly, these galaxies seem distinct from those familiar to us, prompting questions about their origin within our universe. Such discoveries of the Webb telescope have raised some big questions. Are we wrong about the age of our universe, or are we wrong about the origin of these galaxies? So, what are these strange lights, and where are they coming from? Well, new discoveries from the Webb telescope have finally revealed this mystery and conclude that what we previously thought about the early universe may need to be revised. This new image from the Webb telescope has revealed that this light is a rich source of Lyman alpha emission. It also provides evidence that galactic mergers were more common in the early universe than previously observed. These mergers, along with intense star formation, played a key role in producing Lyman alpha emissions. However, scientists once believed that these emissions should have been obscured by the dense hydrogen clouds that filled intergalactic space during the Dark Ages, making them undetectable. Yet they are visible. Recently, researchers discovered that as stellar mass accumulated and stars formed in these early galaxies, two significant events occurred. The stars emitted Lyman alpha emissions, and they carved out bubbles and channels of ionized hydrogen within the light-blocking clouds. Neutral hydrogen gas, the bubbles and channels allowed Lyman alpha emissions through. So this shows that the stars could detect objects beyond the Dark Ages. Surprisingly, in another recent deep field image, scientists found two galaxies that existed beyond the darkness of the early universe. Scientists are now saying that these galaxies are not like the ones we have seen. On the other hand, both of these galaxies are highly redshifted, and astronomers claim that this would be a serious problem if these objects are indeed galaxies. This graph representation provides a comprehensive overview of distant galaxies as seen through the remarkable capabilities of the Webb telescope. This image showcases some of the most distant galaxies confirmed through spectroscopic observations. Among them is GN-Z11, located about 13.2 billion light-years away, first detected by the Hubble telescope. A recent observation from the Webb telescope has unveiled something remarkable. Astronomers have discovered a supermassive black hole at its core. This makes it the most distant black hole ever recorded, forming just 400 million years after the Big Bang. Its immense size challenges existing theories on black hole formation. Scientists are saying that the size of this supermassive black hole does not fit with the time period of the universe because the death of the first stars or the merger of black holes in the early universe cannot create such a large black hole. We need a completely new way of thinking about the formation of these massive black holes so early in the universe. But wait, there is something else in this data that has shocked astronomers around the world. As we can see, these galaxies are the most distant ever discovered by the Webb telescope. The red markers indicate galaxies that have been confirmed through spectroscopic observations. Currently, the farthest confirmed galaxy is named GZ-130, which existed approximately 13.47 billion light-years away. However, there's something even more intriguing in this data. Here, we can observe two galaxies located at a redshift of around 16, meaning they existed beyond the dark ages. This is surprising because, according to standard cosmological models, galaxies were expected to form at the end of the dark ages. Yet these massive and unusual galaxies suggest otherwise. Their existence challenges our current understanding, indicating that galaxies may have formed much earlier than previously predicted. The big question now is, how do we account for the existence of these galaxies? One possible explanation is that our universe might be significantly older than we currently estimate. Alternatively, something unexpected could have occurred in the aftermath of the Big Bang. Perhaps a previously unknown mechanism that rapidly accelerated the formation of early galaxies. As of now, detailed spectroscopic observations of these galaxies have yet to be conducted. However, if future spectroscopic studies confirm their predicted redshifts, it could pose a serious challenge to the fundamental principles of cosmology as we understand them. In other words, our current models of the universe's evolution might require a major revision. Interestingly, another hypothesis has been gaining traction among scientists: the concept of conformal cyclic cosmology, CCC. This theory, proposed by physicist Roger Penrose, suggests that the universe undergoes an endless cycle of expansion, contraction, and rebirth. If CCC holds true, it could offer an explanation for the presence of these unusually ancient galaxies, implying that remnants from a previous cosmic cycle may have influenced the structure of our current universe. Ultimately, whether these galaxies force us to rethink the age of the universe, reveal new physics beyond the Big Bang, or support alternative cosmological models, they undoubtedly hold the potential to revolutionize our understanding of the cosmos. Nobel laureate Dr. Roger Penrose says that there was a universe before us, which he refers to as the previous eon, and that black holes evaporate at the end of the previous eon, as predicted by Stephen Hawking, and the evaporated energy from that black hole gives birth to the Big Bang of the next eon. He also postulates that dead black holes from the past universe accelerated the expansion of our early universe. Scientists propose that these ancient dormant black holes from a previous universe could be the key to understanding the formation of supermassive black holes and the emergence of massive galaxies in the early cosmos. The discoveries made by the James Webb Space Telescope JWST continue to challenge and reshape our understanding of the universe, unveiling phenomena that defy conventional astrophysical models. In just its first 3 years of operation, JWST has shattered numerous cosmic records, revealing the farthest known celestial objects ever observed. These milestones include the most distant galaxy, the most distant protocluster of galaxies, the farthest known black hole, the most distant red supergiant star, the most remote gravitational lens, and the earliest quasar ever detected. Each of these groundbreaking findings pushes the boundaries of our knowledge, opening new avenues for exploration and deepening the mysteries of the universe's origins. These findings open up intriguing possibilities about the true nature of our universe. It might be far older than we ever imagined, or perhaps it exists as part of a vast network of interconnected universes. Another possibility is that the universe has no definitive beginning at all. It may have always existed in some form. Given the seemingly infinite expanse of the cosmos, the idea of an infinitely old universe becomes increasingly plausible. What we traditionally understand as the Big Bang might not have been the absolute beginning, but rather a significant event within an ever-evolving, timeless cosmic framework. Instead of a singular origin point, the universe could be an ongoing causal set, continuously shifting and transforming.